Hello world. This video provides an overview of the new architecture of React Native and its impact on React Native's future. React Native 0.76 with a new architecture by default is now available on NPM. The new architecture adds full support for modern React features, including Suspense, transitions, automatic batching, and use layout effect. The new architecture also includes new native module and native component systems that let you write type-safe code with direct access to native interfaces without a bridge. Most apps will be able to adopt React Native 0.76 with the same level of effort as any other release. The most popular React Native libraries already support the new architecture. The new architecture also includes an automatic interoperability layer to enable backward compatibility with libraries targeting the old architecture. What is the new architecture? The new architecture is a complete rewrite of the major systems that underpin React Native, including how components are rendered, how JavaScript abstractions communicates with native abstractions, and how work is scheduled across different threads. Although most users should not have to think about how these systems work, these changes bring improvements and new capabilities. In the old architecture, React Native communicated with a native platform using an asynchronous bridge. To render a component or call a native function, React Native needed to serialize and enqueue native functions calls with the bridge, which would be processed asynchronously. The benefit of this architecture is that the main thread was never blocked for rendering updates or handling native module function calls, since all work was done on a background thread. However, users expect immediate feedback to interactions to feel like a native app. This means some updates need to render synchronously in response to user input, potentially interrupting any in-progress render. Since the old architecture was only asynchronous, it had to be rewritten to allow for both asynchronous and synchronous updates. Additionally, in the old architecture, serializing function calls over the bridge quickly became a bottleneck, especially for frequent updates or large objects. This made it hard for apps to achieve 60+ FPS reliably. There were also synchronization issues. When the JavaScript and native layer got out of sync, it was impossible to reconcile them synchronously, resulting bugs like lists showing frames of empty space and visual UI jumps due to intermediate states rendering. Finally, since the old architecture kept a single copy of the UI using the native hierarchy, and mutated that copy in place, layout could only be computed on a single thread. This made it impossible to process urgent updates like user inputs, and layout could not be read synchronously, such as reading in a layout effect to update the position of a tooltip. All of these problems meant that it was not possible to properly support React's concurrent features. To solve these problems, the new architecture includes 4 main parts. New native module system, new renderer, the event loop, and removing the bridge. The new module system allows the React Native renderer to have synchronous access to the native layer, which allows it to handle events, schedule updates, and read layout both asynchronously and synchronously. The new native modules are also lazily loaded by default, giving apps a significant performance gain. The new renderer can handle multiple in-progress trees across multiple threads, which allows React to process multiple concurrent update priorities, either on the main thread or a background thread. It also supports reading layout from multiple threads synchronously or asynchronously to support more responsive UIs. The new event loop can process tasks on the JavaScript thread in a well-defined order. This allows React to interrupt rendering to process events, so urgent user events can take priority over lower priority UI transitions. The event loop also aligns with web specifications, so we can support for browser features like microtasks, mutation observer, and intersection observer. Finally, removing the bridge allows for faster startup and direct communication between JavaScript and the native runtime, so that the cost of switching work is minimized. This also allows for better error reporting, debugging, and reducing crashes from undefined behavior. The new architecture is now ready to be used in production. It is already being used at scale at Meta in the Facebook app. New native modules. New native module system is a major rewrite of how JavaScript and the native platform communicate. It's written entirely in C++, which unlocks many new capabilities, like synchronous access to and from the native runtime, type safety between JavaScript and native code, code sharing across platforms, and lazy module loading by default. In the new native module system, JavaScript and the native layer can now synchronously communicate with each other through the JavaScript interface, without the need to use an asynchronous bridge. This means your custom native modules can now synchronously call a function, return a value, and pass that value back to another native module function. With a new architecture, you can finally leverage the full power of a C++ native implementation while still accessing it from JavaScript or TypeScript APIs. The new module system supports modules written in C++, so you can write your module once, and it works across all platforms, including Android, iOS, Windows, and macOS. Implementing modules in C++ allows for more fine-grained memory management and performance optimizations. Additionally, with CodeGen, your modules can define a strongly typed contract between the JavaScript layer and the native layer. From our experience, cross-boundary type errors are one of the most common sources of crashes in cross-platform apps. CodeGen lets you overcome those problems while also generating boilerplate code for you. Finally, the modules are now lazily loaded. They are loaded in memory only when they are effectively needed rather than at startup. This reduces the app startup time and keeps it low as the application grows in complexity. The new renderer. Native renderer has been completely rewritten, adding several benefits. Updates can be rendered on different threads at different priorities. Layout can be read synchronously and across different threads. The renderer is written in C++ and shared across all platforms. The updated native renderer now stores the view hierarchy in an immutable tree structure. This means that the UI is stored in a way that cannot be changed directly, allowing for thread-safe processing of updates. This allows it to handle multiple in-progress trees, each representing a different version of the user interface. As a result, updates can be rendered in the background without blocking the UI, such as during transitions or on the main thread, like in response to user input. By supporting multiple threads, React can interrupt a low-priority update to render an urgent one, such as those generated by user inputs, and then resume the low-priority update as needed. The new renderer can also read layout information synchronously and across different threads. This enables background computation for low-priority updates and synchronous reads when needed, such as repositioning a tooltip. Finally, rewriting the renderer in C++ allows it to be shared across all platforms. This ensures that the same code runs on iOS, Android, Windows, macOS, and any other React Native supported platform, providing consistent rendering capabilities without needing re-implementation for each platform. This is a significant step towards many-platform vision. For example, view flattening was an Android-only optimization to avoid deep layout trees. The new renderer, with shared C++ core, brings this feature to iOS. This optimization is automatic and does not require setup. It comes for free with the shared renderer. With these changes, React Native now fully supports concurrent React features like Suspense and transitions, making it easier to build complex user interfaces that respond quickly to user input without delays or visual jumps. These new capabilities will be leveraged in future to bring more improvements to built-in components such as flat list and text input. The event loop. New architecture implements a well-defined event loop processing model. Implementing a well-defined event loop closes gaps between React DOM and React Native. The behavior of a React Native application is now closer to the behavior of a React DOM application, making it easier to learn once and write anywhere. The event loop brings many benefits to React Native, like the ability to interrupt rendering to process events and tasks, closer alignment with web specifications, and foundation for more browser features. With the event loop, React is able to predictably order updates and events. This allows React to interrupt a low-priority update with an urgent user event, and the new renderer allows us to render those updates independently. The event loops also aligns the behavior of events and tasks like timers with web specifications, which means React Native works more like what users are familiar with in the web, and allows for better code sharing between React DOM and React Native. It also allows for the implementation of more compliant browser features like microtasks, mutation observer, and intersection observer. These features are not ready to use in React Native yet, but are being planned for future. Finally, the event loop and the new renderer changes to support reading layout synchronously allow React Native to add proper support for use layout effect to read layout information synchronously and update the UI in the same frame. This allows you to position elements correctly before they are displayed to the user. Removing the bridge. In the new architecture, React Native's dependency on the bridge has been removed, replacing it with direct, efficient communication between JavaScript and native code using JavaScript interface. Removing the bridge improves startup time by avoiding bridge initialization. For example, in the old architecture, in order to provide global methods to JavaScript, a module would need to be initialized in JavaScript on startup, causing a small delay in app startup time. The rewrite also improves error reporting, particularly for JavaScript crashes at startup, and reduces crashes from undefined behavior. If crashes occur, the new React Native dev tools simplify debugging and support the new architecture. The bridge remains for backward compatibility to support gradual migration to the new architecture. In the future, the bridge code would be removed completely. Gradual migration. Most apps can be upgraded to 0.76 with the same effort as any other release. When you upgrade to 0.76, the new architecture and React 18 are enabled by default. However, to use concurrent features and gain the full benefits of the new architecture, your app and libraries will need to be gradually migrated to fully support the new architecture. When you first upgrade, your app will run on the new architecture with an automatic interoperability layer with the old architecture. For most apps, this will work without any changes, but there are known limitations with the interop layer, as it does not support accessing custom shadow nodes or concurrent features. To use concurrent features, apps will also need to be updated to support concurrent React by following the rules of React. The overall strategy is to get your application running on the new architecture without breaking existing code. You can then gradually migrate your app at your own pace. For new surfaces that have migrated all modules to the new architecture, you can start using concurrent features immediately. For existing surfaces, you may need to address some issues and migrate modules before adding concurrent features. You can check library compatibility with the new architecture on the React Native directory website. As you can see in the screen, we can check if the library has the status as supports new architecture. The new architecture includes full support for React 18, concurrent features, and use layout effect in React Native. The new features in React Native 0.76 include transitions, automatic batching, use layout effect, and full support for Suspense. Transitions. Transitions are a new concept in React 18 to distinguish between urgent and non-urgent updates. Urgent updates reflect direct interaction, like typing and pressing. Transition updates transition the UI from one view to another. Urgent updates need immediate response to match our intuitions about how physical objects behave. However, transitions are different because the user doesn't expect to see every intermediate value on screen. In the new architecture, React Native is able to support rendering urgent updates and transition updates separately. Typically, for the best user experience, a single user input should result in both an urgent update and a non-urgent one. Similar to React DOM, events like press or change are handled as urgent and rendered immediately. You can use the Start Transition API inside an input event to inform React which updates are transitions and can be deferred to the background. Separating urgent events from transitions allows for a more responsive user interface and a more intuitive user experience. Automatic batching. In upgrading to the new architecture, you will benefit from automatic batching from React 18. Automatic batching allows React to batch together more state updates when rendering to avoid the rendering of intermediate states. This allows React Native to be faster and less susceptible to lags, without any additional code from the developer. Use layout effect. In the new architecture, proper support has been added for use layout effect in React Native. In the old architecture, you needed to use the asynchronous onLayout event to read layout information of a view, which was also asynchronous. As a result, there would be at least one frame where the layout was incorrect until the layout was read and updated, causing issues like tooltips placed in the wrong position. The new architecture fixes this by allowing synchronous access to layout information in use layout effect. This change allows you to read layout information synchronously and update the UI in the same frame, allowing you to position elements correctly before they are displayed to the user. Full support for Suspense. As shown in the screen, Suspense lets you declaratively specify the loading state for a part of the component tree if it's not yet ready to be displayed. Until now, React Native was not able to support concurrent rendering for Suspense. The new architecture includes full support for Suspense introduced in React 18. This means that you can now use Suspense in React Native to handle loading states for your components, and the suspended content will render in the background while the loading state is displayed, giving higher priority to user input on visible content. How to upgrade. Please use the React Native Upgrade helper to view code changes between React Native versions for existing projects, in addition to the upgrading docs. If you use Expo, React Native 0.76 will be supported in Expo SDK 52. To take full advantage of the new architecture and to start using concurrent features, you will need to migrate your custom native modules and native components to support the new native module and native component APIs. Without migrating your custom native modules, you will not get the benefits of shared C++, synchronous method calls, or type safety from CodeGen. Without migrating your native components, you will not be able to use concurrent features. Migrating all native components and native modules to the new architecture is recommended. For app developers. If you are an app developer, to fully support the new architecture, you will need to upgrade your libraries, custom native components, and custom native modules to fully support the new architecture. You can consider gradual transition. You can opt out of the new architecture if libraries or components aren't ready yet. Checking library compatibility. You can check library compatibility with the new architecture on the React Native directory website. As you can see in the screen, we can check if the library has the status as supports new architecture. For non-compatible libraries. If any of the libraries your app depends on are not compatible yet, you can open an issue with the library and ask the author to migrate to the new architecture. If the library is not maintained, consider alternative libraries with the same features. Or you can opt out from the new architecture while those libraries are migrated. If your app has custom native modules or custom native components, they are expected to work fine. However, it is recommended to upgrade them to the new native module and native component APIs to fully support the new architecture and adopt concurrent features. For library maintainers. If you are a library maintainer, please first test that your library works with the interop layer. If it does not, please open an issue on the new architecture working group. To fully support the new architecture, it is recommended to migrate your library to the new native module and native component APIs as soon as possible. This will allow users of your library to take full advantage of the new architecture and support concurrent features. Opting out. If for any reason, the new architecture is not behaving properly in your application, there is always the option to opt out from it until you are ready to turn it on again. On Android, you need to modify the Android/Gradle.properties file and turn off the new arc enabled flag. On iOS, you can reinstall the dependencies by running the command mentioned in the screen. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up, subscribe to the channel, and hit the bell icon so you never miss an update. Also, feel free to share this video with your friends. See you in the next one.